All right, welcome everybody. So today we're going to be talking about linear equations, basically lines, all about them. So I think for those of you, I think for everybody really, this will be something that you is familiar to you. You've seen it at some point in time, even if you graduated 20 years ago, this was a big part of your high school math, whether it be algebra 1 or integrated math, whatever. This should be something that everybody feels pretty comfortable with. So we're going to start off with standard form for the equations of a line. Okay, so we can tell this is linear. It's a line because x is to the first and y is to the first. We talked about that in the section where we were trying to figure out if something was a function. We said if both x and y are to the first power, then it's a line. So it passes the vertical line test. So it's a function. Okay. So right away we see x is to the first power. There's the 1, right? We don't write it, but there's ones. So we know we're looking at a line here, right? Now, whenever x and y are on the same side of the equal sign, like in this first example, here's my equal sign, right? Right here. Okay. They're both on the same side of the equal sign. That's what we're going to call standard form. So often when it's in that form, a good way to get a quick line is to use x and y intercepts, like this is saying. So we already know that to find x-intercepts, you let y be 0, and to find y-intercepts, let x be 0. We've been talking about that quite a bit, so we should be getting pretty good at that now. Just put for x-intercepts, let y equals 0. Y-intercepts, let x equals 0. All right, so let's go ahead and do this. And this is nice and easy compared to other things where we've been finding intercepts. All right, so we're going to go ahead and substitute 0 in for the y, right? Okay. All right, so the 2 times 0 piece is going to go away because it's going to be 0. So we have 3x equals 6. We'll divide by 3. And 6 divided by 3 is 2. So that means 2, 0 is going to be our x-intercept. So I've graphed it right there. Now we're going to let the x be 0. I'm writing the equation out, and I'm going to put a 0 in where the x was. Okay. So if we do that, then this part's going to go away because 3 times 0 is 0. And so now we have to divide both sides by -2. So we're looking at the point 0, -3. That's going to be our y-intercept. And so now that we have 2 points determine a unique line. So that has to be the line. Okay, so if you're in standard form, using x and y-intercepts is a very quick and easy way to get the line, guys, the graph of the line. All right, so this one, I probably wouldn't use x and y-intercepts. And so you notice that there's only one variable. So if there's only one variable, which will be our next 2 examples, then just solve for the variable, okay? So if there is only one variable, solve for it. It should be either a vertical or horizontal line. If it's x equals some constant, then it's going to be vertical. If it's y equaling some constant, then it's horizontal. Oops. Okay. I'm going to go ahead and put some space to really emphasize this piece right here. There we go. Okay. So if we go in here and we solve for the variable, just like you guys have been doing all class, so you're really good at it by now. We're dividing by 5, and so we get x equals -2. So this is, I'm going to go to where x equals -2. So there's -1, -2. Write it off to the side here. So this is going to be a vertical line going through x equals -2. Okay. So, why a vertical line? A lot of students get confused. They'll graph it sideways or horizontal because the x-axis is horizontal. But when you're graphing x equals -2, all of the points on that line have an x value of -2. Like this point right here would be -2, 1. This point right here, for example, that'd be -2, 4, etc. All the points along here are going to have -2 as their x value. That's why we call it the line x equals -2. Okay, let's try the next one. It's very similar, you guys. So since it's a y equals, we know this one is horizontal. Since it's y equals a constant, it's horizontal. So we're going to go ahead and draw a horizontal line through y equals 2. So everywhere on that line, sorry, here we go. Everywhere on that line, y should equal 2. So if you pick a few points, right, this would be -3, 2. So yes, the y value is 2. If you go right here, this would be 1, 2. So again, the y value is 2. So we did a great job on that. Okay, so this I know is going to bring back some memories for you guys. This is our formula, right, for the slope of a line. So basically, how to measure how steep a line is. Is the line really shallow? Is the line really steep? Okay, so this is what's going to tell us if it's going to be shallow or steep. So it's going to look familiar how we label it, because you guys did that section on distance and midpoint, right? So we're going to call this x1 and y1. We're going to call this x2 and y2. And we're just going to substitute it in, okay? N is y2 minus y1 over x2 minus x1. Now, the one thing you want to remember when it comes to that formula is make sure that you have y on top. I think our OCD and neatness would want to put x on top, but it has to be, if you recall from high school, the rise over the run, right? The rise is going to be the up and down movement, aka the y, because we know that the y-axis is the up and down one, right? So the y, the rise, over the run, the x, okay? So you've got to make sure, there's one thing to take away, make sure you put y on top, okay? All right, so let's go ahead and substitute in y2 minus y1 over x2 minus x1. So -11 over, and we know that that's going to end up becoming, this two negatives is going to end up becoming a plus, right? So 1 plus 2 should make this 3. So that's going to be our slope, which gets the variable m. Okay. Let's try it again. So let's label these guys. X1, Y1, X2, Y2. I'm just going to write the formula down so that we memorize it. Too much effort in. Okay, maybe I'll keep it black. All right, so y2 minus y1 over x2 minus x1. Okay, so we know that these two negatives right here are going to become plus addition. So that's going to end up being 1.7 then. And then this one will end up being -0.4. Now, typically, you don't want to give an answer like this. I mean, a decimal within a fraction, ugh, nobody wants to look at that. So you guys would have a calculator. I didn't bring mine here to where I'm doing the notes. So I'm just gonna have to do it by hand really quickly. Me. Okay, so it's gonna be 4 1/4 or 4.25. So This is going to be negative 4.25. That's way better for somebody to look at than it is for them to look at this decimal fraction combo. Yikes, right? Okay. So if you ever see a decimal fraction, you want to make sure that you turn that into one number for people to look at. Okay, just much kinder. All right, so negative 4.25 is going to be our slope for the line that goes through those 2 points. All right, so this one says find the slope of the horizontal line y equals 4. So if we were to graph y equals 4, you would simply go 4 spaces on the y-axis, and we would draw a horizontal line. Oops, there's 4 spaces. And then we would draw a horizontal line that goes through that. So now we want to know what is the slope of that. So just using your intuition, we said slope tells us how steep something is, right? If you looked at this line, would you say it was steep? Not at all, right? And so that is why all horizontal lines have a slope of 0. Okay. All right, now let's go over to the vertical line x equals negative 3 then, okay? So we'll get our xy axis going, our axes going. We're going to go to our x equals negative 3. Just right there. And we're going to draw a vertical line through that. It's got to go through the x-axis, right? Oops. Let's try that again. There we go. So it's got to go through the x-axis. Now that one, that is so steep. In fact, it's almost like too steep. Like we're never going to come across that scenario in the real world as far as like if I'm trying to climb something. I mean, rarely, right? Like a treadmill, you know how your treadmill has an inclination on it, you can incline it. And then like your treadmill starts off flat, starts off with a slope of 0, and you can push the incline button and make your treadmill go higher and higher and higher. There's no treadmill like this, right? Okay. A lot of times in the real world, we'll use slope for things like handicap ramps. Handicap ramps can't be too steep, you know, for obvious reasons. If someone doesn't have like an electrical handicap ramp, you don't want it to be like this because they'll be working really hard to get up that ramp, right? So there's a certain range of numbers a handicap ramp can be within for its slope. Roofs actually have a gradient or a slope that they're allowed to. If you're in a snowy place, the roofs tend to be very sharp like this because they want the snow to melt and fall off, right? They don't want flat roofs there, okay? But you're not gonna have a roof that's like this, that's straight up and down. That's impossible, right? Okay. So this vertical line thing, it's kind of hard to decide what slope to give that, huh? It's like, okay, this is clearly 0, but what do I give vertical line? So for that reason, the slope is going to be undefined for vertical lines. Okay, or no slope, right? Okay. All right, now a couple different ways to think about this aside from just using some logic is you can actually go through and do the math. Let's say I pick a couple points on the line. Okay, so let's see, 1, 2. Let's say that I pick 1, 4, and I also pick 3, 4. And these are the points that I decide to do the slope formula to. So we've got to label them. X1, Y1, X2, Y2. Let's go substitute in. Y2 minus Y1 over X2 minus X1. So it would be 4 minus 4 over 3 minus 1. 4 minus 4 is 0. 3 minus 1 is 2. So 0 divided by 2, well, that's 0. Okay, so the slope here would be 0. If we went over and we picked a couple points on, on this one, let's say we pick this point and this point. So 1, looks like that's 4, right? So negative 3, 1 and negative 3, 4. If we were to pick those points, And then we were to label them, right? X1, Y1, X2, Y2. Y2 minus Y1 over X2 minus X1. We're going to substitute those guys in. So the top would be 4, take away 1. And the bottom would be -3, take away -3. Now remember that the minus will become a plus, okay? So the top 4 minus 1 is 3. -3 plus 3, though, is 0. We talked about this earlier in the class. Division by 0 is not allowed. You can't figure out how many times 0 goes into 3. Technically, somebody could say there's 7 zeros inside of 3, a million zeros inside of 3, right? So because it's an unanswerable question, we get undefined. So 0 on the top of a fraction, we said was 0. 0 on the bottom is undefined. So this kind of sums up what we just said, these two on the right, right? We talked about those. So as far as slope being positive or negative, okay, if you were moving from left to right, like you're reading a book and you put a little man here, you know, he's going to have to climb uphill. So that would be positive slope. If we went from left to right on this line, the guy would be going downhill. So we call that negative slope. The treadmills at the gym have a negative slope on them. And so one day I go there, it's like January when everybody's got their New Year's resolution. So it's packed, right? And there's this broken treadmill, but we got to use it because all the treadmills are taken, and it's stuck on negative slope, negative inclination. And so my friend is really trying to get it work out, you know, and I'm like, I'll switch with you. Because I was thinking that, you know, downhill, that's going to be super easy, right? I was so sore trying to run downhill on that thing. Anyhow, so yeah, you always want to read it like a book from left to right. Another way to think about it is if you have a vertical line, anything to the right of it would be positive. Anything to the left of it would be negative. Okay, that's another way to think of it. Besides, would a man have to climb uphill or would a man be going downhill? Okay. All right. So now the very famous y equals mx plus b, aka the slope intercept form. Okay. So this is called slope intercept because we're just great at naming things. We mathematicians, right? Why would I call this slope intercept? Because I have my slope and I have my y-intercept. So let's call the thing slope intercept. Okay. So the first thing we're going to need to do is we're going to have to get this into slope intercept form before we can even use that formula, right? Okay. So get into, oops, I don't know what I just did. Take 2, let's try this again. Okay, get into slope intercept form. By isolating the y, right? And y equals mx plus b, the y is by itself. All right, so let's go ahead and do that. We're going to move 2x over to the other side. And the order does kind of matter, you know? I mean, not really, you're technically not wrong. But if my goal is y equals mx plus b, then I'm going to put the 2x before the minus 6, okay? So it's starting to look like y equals mx plus b. Now I'm going to divide by 3 to everybody. So that's going to get me y equals 2/3 x minus 6 divided by 3 I can do, so I will. The 2 divided by 3 I couldn't do, so I won't, right? So this is in slope intercept form. So remember we said in the y equals mx plus b, the m is your slope. So the slope is going to be 2/3. And the b is going to be, if you look up here, 0 comma b, right? It's going to be 0 comma whatever the last number is. So 0, -2. Okay. So 0, -2, the last number is our y-intercept. We always start with that. Okay, so you're going to do that first. Okay, so graph the y-intercept first. then do the slope. And make sure that you know it's a y-intercept. I get so many students who did such a great job with the slope, but then they put that first dot on the x-axis. It's like, oh man, almost. Okay. All right. Now, the next thing that you want to do after you've graphed it is you want to think about the slope. So the top can either go up or down. Remember, we said it's the rise, so it's going to go up or down over the run. So the bottom is going to be left or right. Up or down, left or right. Okay. So how you can tell which one you're going to pick is the sign. It's a +2, so I'm going to go up. It's a +3, so I'm going to go right. So how we're going to move from that very first dot that we put is we are going to go up to right 3. So I'm going to go up 1, 2, and then from there I'm going to go right 1, 2, 3. That's where our next dot should end up. We're going to do it again. We're going to go up 1, 2. We're going to go right 1, 2, 3. I got off my paper a little bit, but that's okay. We can imagine if it continued, right? Now, you could also do the exact opposite of that. You could go down 2 and left 3, and you'll still be on the same line. So if you ever run out of graph paper, right, just do the exact opposite. Instead of like up and to the right, go down and to the left, and you'll have it. So that's going to be our line, you guys. It's going to be our line. And it's slanting towards the right, as it should be, because it had positive slope. Our little man would have to climb uphill. So I know I have my line facing the right way. Now I do that little reflection, whether it's facing the right way, because that's the number one thing students miss when I'm grading it. It's slanting the wrong way. So if when you get done, you're like, okay, let me go over here. My slope is positive, then it should be slanting towards the right. Cool. Let me check it out. All right, let's go through it again, become pros at it. So we know that we want to get the y by itself. So we're going to move the y over here so that it, well, yeah, let's just do it. I think most people would be comfy with that. And then we'll move the x over here. They're going to trade spots essentially. So it would be a +2y because it crossed the equal sign, and it would be a -x since it too crossed the equal sign. So our last step, divide by 2 to everybody. Now remember, what's in front of that x? Technically, there is a -1, right? Right here that we don't write. So that's going to make this -1/2 x, and then 4 divided by 2 is 2. So now we have it in our slope intercept form. We can clearly see our slope and we can see our y-intercept. All right, so let's see what we get, you guys. So our slope, our m, is, now I put the negative with the 1. You can technically put it with whatever you want, the 1 or the 2, top or bottom, okay? You have to pick though, you don't want it ambiguously off to the side, right? You don't want this where it's, because it's like, well, who does he go with, right? Some students accidentally put it with both. Now pick one to put it with. Then our b is going to be the point 0, 2. Remember the last number is your y-intercept. So we're going to start there. We're going to go up 2 and we're going to put our dot. Now from there, we got to figure out our slope. You know, we have to decide, am I going to be going up or down? Am I going to be going left or right? Well, it's a -1, so I'm going to be going down. It's a +2, so I'm going to be going right. So we're going to go down 1, right 2, down 1, right 2. So down 1, right 2. We'll put a dot. And we'll do it again. Down 1, right 2. We'll put a dot. And as we said before, you can always do the exact opposite too. Instead of down and to the right, you could go up and to the left, and you should be on the same line, right? Doesn't matter. All right, so let's go ahead and draw our line. Boom. Let's do a little check of that slope, you guys. We had a negative slope, and this one is slanting towards the left of vertical. This guy would have to go downhill, right? So that looks good. Looks like we have it slanting the correct way. Write the equation of the line in slope intercept form that passes through the point -2, 3 and has slope. So we're going to use this y equals mx plus b twice. So I'm going to go ahead and write them down twice. The first time, you're going to substitute in these pieces. The next time, you're only going to substitute in those two variables, okay? So let's go ahead and label stuff up here. We know this is the x and this is the y. I'm not going to subscript them because there's only one point up here, right? So no need to subscript. And we know that the slope is m. So we are going to substitute in for the y a 3, for the m a 5, and for the x a -2. And we're going to solve for b, you guys. So 5 times -2 is -10. We'll add 10 to both sides. Okay, so the next time through, all we're going to substitute in is the m and the b. So now we have a line that is in slope intercept form. Somebody could quickly graph this. They could see the y-intercept and they can see the slope. Okay. Now the average rate of change, this shows up in physics and calculus, okay? That we need to know that the average rate of change is synonymous with or the same as the slope, you guys. So if you ever see directions that say, find the average rate of change, just go, boom, I got this slope. Because could be kind of scary. So, you know, the heck does that mean? It's kind of, they show up in word problems a lot, but just read the word problem. And as soon as you see those words, you're like, okay, I just need to get the slope of this, okay? All right, now you'll notice something's happening on this graph over here. Remember we said instead of y's, we were now going to use f of x's. So on this slide, you can see they rewrote, instead of y2 minus y1 over x2 minus x1, they have f of x2 minus f of x1 over x2 minus x1. So they just replaced all the y's with f of x's, you guys. That's it. And even over here on in the picture, your ordered pair, you know, here's your x value, comma, your y value, but look what they replaced the y value with, right? Okay. So this idea of y is slowly becoming f of x, you know, we really want to get used to that, especially those of you that are continuing on to do calculus, okay? All right, so let's go ahead and compute the average rate of change between these 2 points. So we're going to be using the same formula. Okay, let's go ahead and substitute in, guys. Let's see what we get. I always like to kind of guess at stuff before I do it. So let's see which 2 points these are. These are, go ahead and graph the line between them really fast. Okay, I'm looking at it, and that's definitely a positive slope, you guys. So when we get done, we should have a positive slope. It looks steeper than 1 to me. So we should get a number bigger than 1. Let's see what we get. All right, y2 minus y1 over x2 minus x1. 2 minus 0 is 2. We know that minus minus is going to become a plus. So 0 plus 1.5 is 1.5. Now, we talked about how you don't want this decimal within a fraction thing, right? We don't want this. So you can divide it out, whatever. I probably will just move the decimal place 1 time and move it 1 time to give me 20 over 15. And then I'll just reduce that, you guys. So I'm going to divide by 5 to both because I don't have my calculator on me. This just seems easy. So it looks like it's going to be 4/3. That is bigger than 1. Okay. So the average rate of change between those 2 points is 4/3. So for every 1 unit on the x-axis, we would expect a rise of 1.3-ish on the y-axis, okay? And it's a positive number, so that looks pretty good. Let's try another one. So if we draw the line between these 2 points from 0, 2 to 2.5, 1, something like this, okay, that we should expect to have a negative slope. So let's see if the average rate of change between those 2 points is negative, okay? So we're going to label x1, y1, x2, y2. Let's substitute it. 1 minus 2 is -1. 2.5 take away 0 is 2.5. So I'm going to move the decimals again, you guys. So I'm going to move it once and once. This is going to give me -10 over 25. And I'm going to divide by 5s to everybody. So 10 divided by 5 is 2. And 25 divided by 5 is 5. It is negative, -0.4. Okay. We expected a negative average rate of change. So that means for every 1 square on the y-axis, let's say I start with this top point. If I go over 1 square on the x-axis, I only go down 0.4 of a square in the y-axis, right? So see, I'm less than halfway, you guys. And if I did it again and I go over 1 square on the x-axis, I'll only go down 0.4 on the y, etc. It's just telling you for every 1 unit on the x, how much you should expect to change on the y-axis. All right. I believe this is our last problem, our last slide. Okay. Now, the intention of this slide is not to bust out a bunch of algebra. It's to use this picture over here. So we're going to do it completely by picture. And some people actually would rather do the math, which blows my mind because it's so much more work. So hopefully I make enough sense to you to where you're like, okay, I'm definitely not going to solve these equations. I'm going to do it using the picture. Because could we go in here and solve this equation? Sure, we could. Okay. But it's asking us, where does 0.05x plus 1, which you'll notice is the blue line. So when does the blue equal, and then 3x minus 4, that's the red line. Okay. Well, if we look at when the blue equals the red, right here, this is the only spot where the blue and the red equal each other. Okay. So I'm going to trace it down to the y-axis. And right there, I'm sorry, the x-axis, right there, that's the, what, 2? 1, 2. So x equals 2 there. That's my answer. How quick that was. Okay. So if you plugged in x equals 2 into the equations, right, they should work and satisfy that equation. Okay. Now you're only giving me an x value. I have some students who will give me the ordered pair. They'll be like 2, 2, Mecklenburg. That's where they equal each other. But remember, if you were to actually go in and solve this thing, right, you know, like I'm just going to quickly kind of do it so people understand what I'm talking about. If I were to quickly solve this, I would subtract 0.05x. I'm going to do it quickly, so don't mind. 0.5. 3 minus 0.5 is 2.5. You would add the 4 over, blah, blah, blah. 5 equals 2.5. And then we would divide by 2.5. And it just so happens to go in twice. See how you get x equals blah, right? In this case, 2. When you solve these equations, in the end, you always get x equals something, right? Okay. So that's why you need to answer it the way that I show you over here, x equals. If you put down 2, 2 as an ordered pair, I'd have to mark you off because that's not what we're looking for here. We're looking for x's only, you guys, x's only, okay? All right, so this one over here, number 14, it wants to know when is the blue less than the red. In other words, when is it lower? So that's how you want to think of it. When is the blue below. Correct. That's the question we want to be answering. Now for these inequalities, it's not a number, right? It's a range of numbers, right? So if I go over here, I notice that right here seems to be where a behavior in the graph changes. After that point, right, or after that line, the red is higher than the blue. Before that point, the red is lower than the blue. So they switch who's on top, in other words, right? In this area, blue's higher, blue's on top. In this area, red's higher, red's on top. So it wants to know, when is the blue below the red? Well, I'm looking at anything to the right of this line, anything this way, you'll see that the blue line is lower than the red line. So when is the blue below the red? My claim is when x is greater than 2. This is 2. This line passed through 2. So as long as I'm greater than 2, I'm to the right of 2, the blue will be below the red. If we go and we look at number 15, now we want to know, when is the blue greater than or equal to the red? Well, the blue is greater than the red on the other side of 2, right? If I look at this, the left side of 2, you can see the blue is higher. Okay, so I'm going to go ahead and say when x is less than or equal to 2. Okay. So if you go to the right of this line, the red is higher. If you go to the left of this line, the blue is higher. So that's why we're saying greater than 2 or less than 2. As far as the or equal to, you guys, just look at the original problem. If it has an or equal to, your answer will have an or equal to. If it doesn't have an or equal to, then your answer won't have an or equal to. Okay. All right. Hopefully that made sense enough for you to be able to go in there and solve problems like that without having to do the number crunching. If you can't, the number crunching will be your plan B. Okay. All right, you guys, that is it for 2.4. Have a great day.